All right, we are moving on to lesson 7.6, and we are doing more quadratic functions. Our essential question is, are you able to analyze a quadratic function to draw its graph, find its max and minimum value? And we're going to do a lot of this by hand, and then we're going to do a lot of it using RTI. All right, the general form that you're used to seeing is ax squared plus bx plus c. Notice they state a can't be 0 here because if I had that as a 0, we wouldn't even have an x squared. So they have to state that, hey, a cannot equal 0. The other form that we're looking at here is called the completed square form. I think we called it standard form yesterday. F of x is equal to a times x minus h quantity squared plus k. So we're going to talk about a lot of things regarding these different forms and what to do with them. So knowing what we know about parent functions now, let's talk about what we know. I know the vertex is going to be positive 3, positive 1. Because the vertex is positive 3 at the x, remember the axis of symmetry is going to be x equals 3. So that is a line in which when I fold the parabola in half, it is going to be symmetrical. So the first thing I'm going to do is I'm going to graph positive 3, positive 1, and I already put my line there. And I also know that this little 2 right here goes with my pattern over 1 up 1, over 1 up 3, over 1 up 5. But because it's a 2, now I have to multiply all the ups by 2. So I probably won't be able to graph it all because I'm going to run out of room, but I have over 1 up 2, over 1 up 6, over 1 up 10. Yeah, I won't be graphing that up 10. So let's graph that. All right, from this dot right here where the vertex is, I'm going to go over 1 up 2. So notice this is a stretch. And I always say we stretch our hands towards heaven. And I'm trying to make it even, but I'm not very good at drawing. From this dot, we're going to go over 1 up 6. 1, 2, 3, 4, 5, 6. Woo, I just made it. Over 1 up, 1, 2, 3, 4, 5, 6. So my parabola is going to be a U shape because it is a positive 2. Remember, if it was a negative 2, it would go upside down. And we know all this from our parent functions. All right, so the max and the min, in this case, we have a min. You have to communicate, hey, we have a min, because it is the smallest point. Sometimes they only talk about the y there, but you can put the whole point there as 3, 1. The domain, remember that the domain is the x, where the range is the y. I am going to look at the domain like I'm reading from left to right. So if I'm reading from left to right, where is this domain starting? This domain, because of that arrow, is starting at negative infinity. So it's starting all the way at negative infinity. And because of this arrow right here, I'm drawing over it in orange, it's going all the way to positive infinity. Now, you can also write that as all real numbers, so I don't care how you write it, whatever makes you happier. The range. Well, we already talked about where the range is starting. The range is starting right here. What number is that range starting on? Good, that range is starting on 1. And notice I put a bracket there. This bracket means that 1 is included. So if it was an open circle, it would be a parenthesis, but this one is a closed circle, so it's a bracket. And we're going all the way to infinity again, because once again, these arrows are going all the way up, so it's showing me that they're going all the way to positive infinity. Now, remember the zeros are solutions, roots, zeros, or x-intercepts. These are when we solve. X is equal to opposite b plus or minus square root b squared minus 4ac all over 2a. Or we could take a look at our x-axis and say, hey, this one isn't touching anywhere. So we know there are no real solutions. But if they're asking you for imaginary solutions, we would have to solve this, okay? So there are no real zeros here. There are no x-intercepts. All right, moving on to the next question. Show that the graph of g of x equals 3x squared minus 12x plus 7 is a parabola. Find the vertex and sketch. Well, the first thing we're going to have to do is we are going to have to take that 3x squared minus 12x plus 7, and I have to complete the square. The first thing I'm going to do to complete the square is I'm going to get that 7 over. So I have, really this was a g of x, so let me show that as g of x. G of x. Remember, an f of x or a g of x is just in place of the y. So I have g of x minus 7 equals 3. I'm going to kill two birds with one stone because I know I could take a 3 out of here, and then I could go ahead and work with completing the square. Those canceled out. But remember, what I add to one side, I have to add to the other. All right, so we have to complete this square. We're going to complete the square by taking half of 4, which is 2, and square it, and we get 4. But notice what's super crazy here is we have to pay attention to this number 3 on the outside. I didn't really add a 4. I added a 12. So I end up with g of x plus 5 is equal to 3 times x minus 2 quantity squared. Remember, our whole goal was to get this right here into a perfect square. And I like to show it as g of x equals 3 times x minus 2 quantity squared minus 5, where I know my vertex, which I just underlined in orange, and I know that this 3 is going to be my over 1 up 1 times 3. Over 1 up 3 times 3. So yes, that's going to get pretty steep. So let me write that form that we just found right here. It was g of x is equal to 3 times x minus 2 quantity squared minus 5. So let's write down what we know. The first thing we know is the vertex. The vertex is at positive 2, negative 5. I really should have graphing paper, but I don't, so I am so sorry. So that is my vertex. I did graph it. My axis of symmetry is just the x, and remember it's written as a line, so x equals 2. I'm going to draw that in like I always do, just because I like the visual of everything. Well, let's go ahead and graph it. I can graph it using this positive 3. My pattern is over 1 up 1 times 3. Over 1 up 3 times 3, and I don't think we're going to go any further than that. So let's graph it. Over 1 up 1, 2, 3. All right, from that dot, now we have to go over 1 up 9, so it's a little bit further. So from this dot right here, I'm going to go over 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoa, this one stretches to the heavens. Over 1 up 9. And it looks like now I have some x-intercepts and some y-intercept, well, one y-intercept. And that is what my parabola looks like. All right, so it does have a minimum. That minimum was at, and I'm going to circle that it has a minimum. That minimum was at 2, negative 5. Some people just show the y, so some people will just show the y part. The domain, remember we read from left to right, so the domain goes from left to right, and because it is an arrow going all the way to the left, an arrow going all the way to the right, even though it's going up, it still is going to the left and to the right. The domain is negative infinity to positive infinity. You could write that as all real numbers, so I'll write that here. My range is up and down. So where did this start? It started right here. It started at that negative 5. That negative 5 is included because it's a filled in circle, and it went all the way to infinity. Now, if you notice these zeros right here, I don't know how to find them. All right, we do have to find our zeros next. So remember, we can use x is equal to opposite b. That's probably your best bet. I'm going to use this equation right here because this was our original. And I'm going to write it in pink. X is equal to opposite of b plus or minus square root b squared minus 4 times a times c all over 2a. Let's see where this brings us. 12 plus or minus, I'm getting my calculator. The square root, I'm just going to put 144 minus 4 times 3 times 7. I did 73, that didn't work for me. And let's try that again. 144 minus 4 times 3 times 7. And that gives me the square root of 60 all over 6. What perfect square comes out of 60? That's going to be 4. 12 plus or minus. So remember, this is a root 4 and root 15, where I get 2 root 15 all over 6. And then I could reduce this by taking out a 2, and I have 6 plus or minus root 15 all over 6, and we can reduce. So my zeros are 6 plus or minus root 15 all over 3. I'm going to write that in. 6 plus or minus root 15 all over, I think I said 6, I meant 3. All right, that's a whole lot of stuff for you guys to know, but this is a great, pretty informative video that's going to show you all the things you need to know about parabolas.